right, by the end of this video, you should be comfortable writing some proofs that involve parallel lines and their angles. We're going to go ahead and talk about how you write a proof when you're given parallel lines and asked to prove angles. So that's how we'll begin. Some reasons that we're going to use in these types of proof is we're going to start out always by talking about the parallel lines. Very, very, very important that you start out talking about the parallel lines, because without the parallel lines, none of these angle relationships hold true. So the first reason that we're going to talk about, or the reason why angles might be congruent, is because when we have parallel lines, those parallel lines will often make, or always make, congruent corresponding angles. So anytime you have a pair of parallel lines, you can always conclude that the corresponding angles that are formed are congruent. The second thing, anytime you have parallel lines, they will always create congruent alternate interior angles. So again, anytime you have parallel lines, you may conclude that the alternate interior angles that are created are congruent. Parallel lines also create congruent alternate exterior angles. So anytime you have lines that are parallel, you may conclude that the alternate exterior angles that are formed are congruent. And then lastly, parallel lines always make same side interior angles that are supplementary. So those are the angle relationships that you know hold true anytime you have a pair of parallel lines. So let's go ahead and take a look at this first proof. We're given that line L is parallel to line M. We're asked to prove that the statement angle 3 is congruent to angle 6 is a true statement. So the very first thing that I'm going to go do is I'm going to go mark my diagram with the information that has been given. To show in my diagram that line L is parallel to line M, I'm going to mark each line with a blue arrow. You too need to mark your diagram right now to reflect that line L is parallel to line M. Once I know that those lines are parallel, I know a whole bunch of facts are true. I know that all their corresponding angles, such as angle 1 and angle 5, are congruent. I know that all pairs of alternate exterior angles are congruent. All pairs of alternate interior angles are congruent. But the one that I specifically want to talk about in this proof are angles 3 and 6. So if I go to the diagram and look at angles 3 and 6 and ask myself, what is true about their relationship with each other? What kind of angles are they? Well, I can see that they're alternate interior angles. And that's one of those relationships that I know holds true whenever lines are parallel. When lines are parallel, which I have in the given, I know that alternate interior angles are congruent, which is what it is that I'm trying to prove. So that's the general direction or the gist of the way that this proof is going to flow. So I'm going to go ahead and begin by talking about the given. The given tells me that line L is parallel to line M. I'm going to write that down and enclose it in a bubble. Underneath, I'm going to write the reason why I know that that's a true statement. And you need to, on your paper, write your notes in your packet exactly the same way as I'm presenting them in the video. So you need to also enclose the statement line L is parallel to line M with a box or a bubble and write the reason underneath. Because this is a true statement, I know that it has to be true that angle 3 is congruent to angle 6. And the reason why I know that is because anytime I have parallel lines, so I'm going to start out by talking about those parallel lines. And those parallel lines make my alternate interior angles congruent. And because at this point I have shown exactly the reason why that's a true statement, or my proof is a true statement, I know that I'm done with my proof. At this point, if you have any questions about exactly what I did in that proof, feel free to write them in the margin so that you'll remember to ask me the next time that you come to class. And in the meantime, let's go ahead and flip up to the next page and we'll get ready to tackle the next one. Number 2 tells us that line L is parallel to line M. So just like the preceding example, the first thing that I'm going to do is I'm going to take my pen or pencil and mark my diagram to reflect the information that is given to me in the problem. You need to mark your diagram on your paper exactly the same way that I marked mine. And then just like before, I'm going to go ahead and take a look at exactly what it is I'm trying to prove. In this case, I'm trying to prove that angle 4 is supplementary to angle 6. So I'm going to go take a look at the diagram and find out where in the diagram these angles are located. Angle 4 and angle 6 are located on the same side of the transversal, inside lines L and M, making them same side interior angles. Well, one of the angle relationships I know is true when lines are parallel is that same side interior angles have to be supplementary. So that is the gist or the direction that this proof is going to have to take. So I'm going to go ahead now and start out by talking about those lines that are given to me to be parallel. And on your paper too, you're going to write that given statement and enclose it, and then write the reason you know it's a true statement underneath. And because those lines are parallel, we know that all sorts of special angle relationships exist. The one that we want to talk about in our proof today is the one that talks about angles 4 and 6 being supplementary. So that's the one that I'm going to write about. I know that angle 4 is angle 4 is supplementary to angle 6. And I have to write a reason now why I know that that's a true statement. Well, anytime I have parallel lines, and I'm going to go ahead and start off by talking about parallel lines first, they make the same side interior angles supplementary. Notice that in both of these statements that I used for example 1 and example 2, I started off talking about parallel lines first. And the reason for that is that none of these angle relationships hold true until the lines are parallel. So it's very important that you talk about those, or that special given statement first. All right, and moving on to the next one, this one too is similar to the two preceding examples. I'm going to start off by marking the information that I know to be true in my diagram. You need to mark that on your paper as well. And then I'm going to take a look at the statement that I'm being asked to prove. In this case, I'm being asked to prove that angles 2 and 6 are congruent to each other. And if I take a look at their relationship, I see that they're corresponding angles. Well, I know anytime two lines are parallel, all sorts of angles are congruent. One of those special pairs is corresponding angles, which 2 and 6 just happen to be. So that's going to be the general direction or the gist that I'm going to write this proof. So I'm going to go ahead and start out by talking about lines L and M being parallel. I know that's a true statement because it's given to me to be a true statement. And if lines L and M are parallel, then I know that angles 2 and 6 have to be congruent. I know a whole bunch of other angles have to be congruent as well, but the ones that I'm being asked to talk about in this proof are angles 2 and 6. And the reason I know that they're congruent is because anytime I have parallel lines, and only when I have parallel lines, those parallel lines make the corresponding angles congruent. Now it's important that you mention in your reason here that these angles are corresponding angles, because just because the lines are parallel, it doesn't make all of the angles congruent in the picture. It only makes certain types of angles congruent. So you have to make sure that you talk about exactly which type of angles 2 and 6 are. All right, at this point, I'm going to flip up to the top of the next page and shift focus a little bit. Up until now, we've used the parallel lines to create certain special angle pairs. Now we're going to talk about what happens when angles are congruent and how that can prove that our lines are parallel. Anytime we have congruent corresponding angles, we know that the lines have to be parallel. So congruent corresponding angles, I'm going to say make parallel lines. Anytime we have congruent alternate interior angles, we know that the lines are going to have to be parallel. I got to get this junk off my paper here. Let's try that again. Congruent alternate interior angles make the lines parallel. Anytime I have congruent alternate exterior angles, that'll make my lines parallel. And lastly, anytime I have same side interior angles that are supplementary, that will also force the lines to be parallel. All right, so let's not waste any time. Let's go jump right into this. Example 4 says angles 3 and 6 are congruent to each other. So just like before, the very first thing that I'm going to do is take that information that was given to me in the problem and mark my diagram so that it reflects that given information. So angle 3, I'm going to mark congruent to angle 6. And then I'm going to go ahead and I'm going to take a look at the relationship between those guys. They're alternate interior angles. They're congruent alternate interior angles. Anytime I have congruent alternate interior angles, I know that that forces my lines to be parallel. And if you look at exactly what it is that we're trying to prove here, we're trying to prove that these two lines are parallel. Well, when the alternate interior angles are congruent, it forces the lines to be parallel. So like the proofs that we wrote on the preceding page, this proof 2 will be a nice, short, direct two-step proof. So I'm going to start out by talking about my given. Angles 3 and 6 are congruent. I know that's a true statement because it's given to us to be congruent. Because those alternate interior angles are congruent, I'm all set to go ahead and make the conclusion that lines L and M are parallel. How do I know that that's a true statement? Well, anytime I have congruent alternate interior angles, they make my lines parallel. Because now I've proven or shown why our proof must be a true statement, I know that my proof is concluded and finished. All right, up at the top of the next page, angle 5 is very similar, except now we're being given that angles 4 and 6 are supplementary. This is a really challenging given to mark in the diagram. To show that two things are supplementary, I don't want to mark them congruent. I'm going to mark angle 4 with one arc and angle 6 with 2, indicating that they are not indeed necessarily congruent to each other. However, because they're supplementary, and I notice that their relationship is such that they're same side interior angles, I know then that lines L and M have to be parallel to each other. That's one of the conditions or the criteria for establishing parallel lines. So this proof 2 is going to be a two-step proof. I'm going to go ahead and start out by saying angle 4 is supplementary to angle 6. I know this is a true statement because it's given to me to be a true statement. And because those same side interior angles are supplementary, I'm all set to go ahead and conclude that those lines have to be parallel. And the reason that I have for that is that when same side interior angles are supplementary, I know that lines have to be parallel. All right, if you have questions, please write them down in the margin of your paper so that you can remember to ask when you come back to class. In the meantime, I'm going to go ahead and shoot on to number 6 and take a look at how that one looks. Again, the very first thing I'm going to do is take a look at the information that's being given to me in the problem, and I'm going to mark my diagram to reflect that information that's been given to me in the problem. So angle 2 and angle 6 are congruent to each other. In looking at the diagram, I can't help but notice that the special relationship that they share is that they are corresponding angles. So I've been given a pair of corresponding angles that are congruent to each other. And that then will force my lines to be parallel, which is what I'm trying to prove. So this too is yet another one of those little two-step proofs. We're going to go ahead and get this thing started. So angles 2 and 6 are congruent. I know that's a true statement because it's given to us to be a true statement. Once I've got those corresponding angles that are congruent, I'm all set to go ahead and conclude that the lines are parallel. And that's because when corresponding angles are congruent, the lines that are there are parallel. All right, I think we'll tackle one more of these for today. I'm going to go ahead and flip up to the top of the next page. It says M is perpendicular to line L, which has already been marked for me in the diagram. And line L is perpendicular. Line N is perpendicular to line L. And we're trying to prove that the two lines have to be parallel to each other. Well, perpendicular, I know, means forms right angles. So I'm going to go ahead and mark these guys as right angles. And I'm going to mark angle 1 as a right angle and angle 2 as a right angle. And there are a whole bunch of more right angles I could have marked in that picture. But I'm going to go ahead and save those, mark just angles 1 and 2 for the time being. I notice that angles 1 and 2 are corresponding angles. They are also both right angles. So if I've got two corresponding angles that are both right angles, and I know that all right angles are congruent to each other, I know that the corresponding angles have to be congruent and that the lines have to be parallel. And this is going to be more than just a simple two-step proof. So I'm going to suggest that as I write the notes here, you write them on your paper. You will probably have some questions that you'll need to ask or clarify when you come back to class the next time, and that's okay. So I'm going to go ahead and talk about my two lines being perpendicular. M is perpendicular to L, N is also perpendicular to L. I know that's a true statement because it's given to me to be a true statement. Now I know that the definition of perpendicular lines says that they form right angles. So because those guys are perpendicular, I know that angle 1 and angle 2 are both right angles. That's what the word perpendicular means. It means that they form right angles. So I'm going to say perpendicular lines make or form right angles. Now, because all right angles measure 90 degrees, they have to be congruent to each other. So because these two guys are right angles, I now know that angle 1 and angle 2 are congruent. And these are going to be some reasons that you haven't seen before in proofs. All right angles are congruent. And lastly, angles 1 and 2 are a pair of congruent corresponding angles. That's going to force our lines to be parallel. So that's going to make line M parallel to line N. And that's because congruent corresponding angles make lines parallel. And whether you realize it or not, you've just done something really significant, and that you've proven your very first theorem in geometry. A theorem is a statement that can be proven using definitions and postulates and unknown terms. And in this case, the theorem that we proved is that anytime you have two lines perpendicular to the same line, they are parallel to each other. So we were given these lines M and M that were both perpendicular to line L, and we proved that they were parallel to each other. So I'm going to say this theorem states that two lines that are perpendicular to the same line are parallel to each other. And I think that that is well and truly good enough for now. If you didn't have a few questions about this last proof that we just took a look at, I'm probably thinking it's because you didn't think about it hard enough. I'm going to guess that you probably do have some questions that need to be asked the next time that you come to class. And if you do, that's okay. In fact, it's probably better than okay. It's good because it means you're actually thinking about the problem. So if you have some that come to mind right now, jot them down so you can remember to ask them. But if not, we will probably review this one when you come back to class, and then we'll head onwards after that. No.